Uh, okay, my name is Thai. I'm at DTINTH on Twitter and GitHub and other places. I come from Thailand, and right now I'm currently working as a software engineer at Open. It's great to be back here in Singapore. Yeah, I've been stuck in Bangkok for about 2 years due to the pandemic. And during those 2 years, there are a few events in person, and then I start experimenting with different formats of talk. So what I started experimenting a bit was like making some part of the talk pre-recorded. So we are going to have like about 15 minutes of pre-recorded video, but I do some intro live. I've done this with a few other talks, and if you're interested, you can look at it at my website, dt.in.th. It's built with WillPlace, by the way. It's the default theme. It's like really flexible. And today I'm going to talk about my topic is amazing flexibility of the Web MIDI API and its surrounding ecosystem. Anyone here play music? Anyone? What kind of instrument do you play? Guitar, bass, violin, piano. Oh, yeah. If you play piano, keyboard, or maybe even bass, you may find this useful. I hope. So, without any further ado, let's go to the pre-recorded video. I'm so nervous about this. Oh, by the way, if you have any feedback about this talk, please feel free to tweet to me at DTINTH. And let's start. Okay. So this is the web page.
Hello everyone. This talk is about the amazing flexibility of the Web MIDI API and its surrounding ecosystem. First, let me introduce myself. My name is Pangsakulyanont. I'm a software engineer, but I also enjoy playing music. What I don't particularly enjoy is having to carry musical instruments around. Still, when I'm outside, I want to be able to play music with friends using just my laptop, plus a few equipments like a speaker. So I built my own web-based setup. I call it Web MIDI-Con, and I show it at JSConf Asia 2016. In 2020, the pandemic happened, and in 2021, we were in lockdown. During that time, I found a software called Jamulus that I can use to play music with friends online in real time. So I and a few friends started jamming from our own homes and live stream it. This attracted more people to join our servers, and our online jamming community started to grow from there. And we got to perform at a few virtual events such as PyCon APAC 2021. It had become my new favorite hobby, and it gave me a lot of motivation to explore about making music using web technologies. And today, I want to share my experience with you, in particular about the Web MIDI API. So let's start with the basics. What is the Web MIDI API? The specification tells us that it provides a means for web developers to enumerate, manipulate, and access MIDI devices. But what is MIDI? Well, MIDI, or Musical Instrument Digital Interface, is a technical standard that describes a communication protocol, digital interface, and electrical connectors that you can read about on Wikipedia. So for this talk, let's see what it lets us do. I'm going to use my browser to demonstrate this. But remember that Web MIDI API is used to access MIDI devices. First, I need to hook a MIDI device to my computer. This is a MIDI cable, and it would be plugged into a MIDI device like an electric piano. As you see, there are separate connections for input and output. Then, using a MIDI to USB adapter, I can connect it to my computer. However, many modern keyboards, such as this one, no longer comes with MIDI ports, and instead just use the USB port. So I'm just gonna plug that into my computer. Now on the browser, I can access my MIDI device first by requesting for a MIDI access. Again, inputs and outputs are separate, so let's look at the input first. MIDI.inputs is a map-like structure, and I can use the for-of loop to enumerate all the input ports. Now I have the port ID. I will use the get method to obtain the port object. Then I will listen to the onMIDI message event. And when I press enter, I start seeing MIDI messages from the keyboard showing up in my console. These messages come as a byte array. Some messages are just a single byte, while some other messages are 3 bytes long. The MIDI specification has a table that shows what each of these messages mean, but they are written in a hexadecimal notation, so I will have to adjust my code to format it accordingly. Now that's better, and we are seeing a bunch of FE. Looking at the specification again, FE corresponds to the active sensing message, which is basically a heartbeat message. So I'll change my code to ignore that. I'll try playing again. When I press the keys, I see status 90, which means note on. And when I release, I see the status 80, which means note off. Let's focus on the note on messages. The specification says that there are 2 data bytes. When I press the same key, the first data byte stays the same, but the second data byte tells me the velocity of hitting the key. And as I play different notes, I get a different first data byte. And with a bit of code and some help from the library Web MIDI.js, I can create a web application that visualizes the MIDI data in real time. Okay, so we've seen MIDI input. Now let's try MIDI output. Again, we start by getting the port that we want. Once we have the port, we can call the send method to send MIDI messages according to the specification. And now my keyboard is making sounds. Let's make it play more notes this time. And that's how we can communicate with a MIDI device. What happened here is when a web app uses the Web MIDI API, the browser will then use the MIDI framework provided by the operating system, which in turn communicates with the MIDI device for us. So, with the Web MIDI API, I created Web MIDI Con, a collection of web-based MIDI control surfaces. Since it's a web app, it can be used on a variety of devices. And by editing the source code, I can customize it to my liking. Most often, I use it to play notes using my PC keyboard. I have set up the key mapping to allow for playing 3 octaves of note at the same time. It also gave me quick access to the transpose function, so I can switch to a different key without having to adjust my fingering. This web application sends MIDI signals but couldn't generate a sound on its own. I need another device that receives these signals and generates a sound. And right now, it's the electric keyboard that you're hearing. But as you know, I don't want to carry that around, so something has to be done.
Oh, sorry.
Fortunately, macOS has an IAC driver. IAC stands for Inter-App Communication. To access it, first I go to the Audio MIDI Setup app and open the MIDI Studio. Then I select the IAC driver and create a new bus. This creates a virtual loopback MIDI cable, which shows up as a new MIDI device. Then I can open an app like GarageBand and send MIDI messages to it. As you can see, there are many ways that applications and MIDI devices can communicate with each other. And this brings us to the second part, ways to connect MIDI. So far, we have seen 2 ways. First, using a USB cable to communicate with a physical MIDI device, and second, using the IAC driver to communicate between apps on the same computer. In this part, I'll show you more examples of how different devices and applications can be connected together to exchange MIDI data. And here we go. Here, I'm running GarageBand on my iPad. I can go to Advanced Settings and select Bluetooth MIDI devices. Then on my audio MIDI setup, I can click on the Bluetooth icon here and pair them up. Once they're paired up, I can now use my iPad as a synthesizer. Next, there is an iOS app called Web MIDI Browser. This is a web browser that provides support for the Web MIDI API. Here, I can use my iPad as a drum pad. Next, when I connect an iPad or an iPhone to my Mac using a cable, I can go to Audio MIDI Setup and enable the inter-device audio and MIDI mode. Once it's enabled, my iPad becomes a MIDI device, and this lets me play with even lower latency. Now, let's look at Android. Google Chrome on Android supports the Web MIDI API out of the box. Here, I plug in the Casio keyboard to my phone via USB, and it just works. Next, on Android, there's also an app called Fluid Synth MIDI. When I launch it, it creates a virtual MIDI device, and I can use this setup to play drums with just my phone. And thanks to the Web MIDI API, I can experiment with different control surfaces. Next up, here I just plug my phone to my computer. Now I can change the USB mode to MIDI. And as you might expect, it shows up as an output port. One more example. MIDI data can also be exchanged over a LAN or a Wi-Fi network. On a Mac, support for MIDI over networks is built into the operating system. And on Windows, you can install the RTP MIDI driver. To set up, first create a session and type in the name. And once the session is enabled, the two machines can now see each other. And then one machine can connect to the other machine, and then they can start exchanging MIDI data. In this example, I'm running Logic Pro on my MacBook. I use my keyboard to play the piano part. My Surface joins the network MIDI session with my MacBook over the Wi-Fi connection, and I use its touchscreen to play the strings part. So, these are some of the ways that MIDI devices and apps can be connected. As of writing this talk, I haven't found a reliable way for Windows and Android devices to exchange MIDI data over Bluetooth yet, but still, I think what we have right now is extremely flexible and allows for a lot of possibilities. I think the web platform is also very flexible and can do so many things today. Imagine what we can do when we combine the power of the web platform and the MIDI ecosystem. So here are some examples that I have experimented with. So the web has a Gamepad API. It lets web applications receive input from game controllers. Here, I use a PlayStation game controller to create a sustain pedal for my keyboard. And if I didn't bring a game controller with me, using the Pointer Events API, my iPhone can also become a sustain pedal. Let's look at a few more examples. Using the device orientation events, I built a modulation wheel with my iPhone. As well as a turntable. I haven't used them personally, but this is just to give you some ideas of what's possible. One last example. The web has a WebRTC API to facilitate real-time communications between browsers. Earlier I said that I couldn't reliably set up a wireless connection on Android and Windows devices using Bluetooth, but here's one way that I worked around it. I created a web application that uses WebRTC to transport MIDI data between connected peers. Here I plug my Android phone to a Casio keyboard. I open the same application on my Windows device, and now I can control my keyboard wirelessly thanks to WebRTC. So these are the examples that I wanted to show you. When I build front-end web applications, usually the experience is confined to a single device unless I set up some kind of a back-end service so that different devices can communicate with each other. When I learned about the Web MIDI API, it totally amazed me. Now, web apps can exchange musical data in real time with different devices over USB, Ethernet, Wi-Fi, and even Bluetooth without having to write any back-end code. And with the Web MIDI API, web applications can themselves become musical devices. In this talk, I've shown you several examples of using a web application as a MIDI controller. But there are web-based MIDI synthesizers as well, thanks to the Web Audio API that provides support for low latency audio in the browser. For example, WebDX7 from the Web Audio Modules project emulates the vintage DX7 digital synthesizer using WebAssembly.
Anyone remember this song?
WebOBXD emulates the OBX analog synthesizer. And there's even a full-on digital audio workstation on the web built by BandLab. So if you are a web developer and you play music, I hope that this talk may give you some ideas or inspiration for you to play with. You can find the links to all the references and resources that I showed on this talk at dt.in.th/webmidi-talk.html. And that's all that I have for now. Thank you.
Okay, that's the pre-recorded part. Thank you. And oh, I need a singer. So, anyone who can sing? Oh, on. Maybe you can help sing. Okay. So this is totally unplanned. Yeah. Okay.
I'm confused now.
Yeah, I didn't. Let's try this one.
Is it on?
So this is the Web MIDI con that I showed earlier. I think it's on. อะไรดีแป๊บนึงนะ อันนี้ได้ไหม How about if I compute? I think you can do that. So I use my keyboard, like my MacBook keyboard this time, and I'll have to turn the volume down a little bit. The synthesizer that I'm currently using is the web-based one called WebDX7. So this is actually like a web app. Yeah, and it emulates a vintage synthesizer. So I can play something like this. One, two, three. Okay. You count. We haven't. Yeah. Now I can get the struggle of doing a talk live. Okay. Go.
Some people want it all, but I want nothing at all. If it ain't you, baby, if I didn't got you, baby. Some people want diamond ring, some just want everything, but everything means nothing if I didn't got you. If I got you with me, baby, there's nothing in this whole wide world gonna mean a thing. If I got you with me, baby.
Yeah. Thank you. Okay. Thank you, On. Thank you very much.
I'm sorry.
Yeah. Cheers. Okay. So I didn't plan to have any extra. So any questions? So we have a group called Music Jamming TH, and as said earlier, we are using the Jamulus application, and you can like launch if you have like a Mac or Windows, you can launch Jamulus and then you can join into our server. So usually I usually play on Jamulus. So yeah, if you find me on the connection screen, then you can come and say hi. Yeah, there are a lot of servers like in Singapore and in Thailand. Yeah, so when there are people inside, you can like join in and then listen to what they're playing, and then you can send your own sounds into the session. Yep. Latency, it can be as low as 18 milliseconds, which is good enough for playing music live. Yeah. Okay.
Wow. Any other questions? I'm just blown away. Oh yeah.
Okay.
Yeah,
thank
we
you.
have.
Thank you. Your products are really, really cool. And I happened previously to work on a web-based audio workstation. So when you should find out we're using web audio APIs, the offline rendering is really slow, particularly if you're trying to render the sound, have hundreds or thousands of media notes, then it's gonna take a minute. Or if longer than that, they could be crashed. So when you're doing like live performance and recording in web-based audio workstation, have you encountered such a situation, or do you? How did you just offline rendering the audio?
Oh,
yeah.
I think. Thank you for the question. And thank you for sharing. Yes, web audio API when you are using the offline mode is pretty slow, and sorry, I don't have an answer to your question. When I play live, I don't use the web-based synthesizer. I just use Logic Pro because I already paid money for that. And yeah, it's easier to use a little bit. Yeah. So if you want to make it faster, one way that I can think of is to render different parts in parallel, similar to like a render farm, but I'm not sure how good it would be. Yeah, but thanks for your question. Sorry.
Brilliant. Yeah, and I think at that point, another big round of applause for Thai.
Thank you, sir. Thank you.
And I think it's actually